Hello guys, so again let's dive into the multi-model series of RAG, that how do you actually make a multi-model RAG system. Okay, so when I tell about the multi-model, right, so instead of document which is only containing the text, now it will going to contain the image, it contains the caption, it contains the title, it contains the table, it contains some other file, it contains the link, it contains some other header. Okay, it is completely like a total real life PDF. Okay, because in real life PDF what you will get, okay, you will get, apart from just a text, right, you are going to get so many image imprinted on it, right? So how do you actually make a complete RAG system over it? Okay, so we will be completely like figuring out the solution, and I would also like to tell you that different methods, right, that how you can actually try to make the complete multi-model RAG and then save it into the vector database. So the procedure will be same. Okay, the entire pipeline would be same, only the minor differences I will be telling in my algorithm, right, which we are actually using it for our purpose, right? So let's just first understand about this multi-model RAG. Okay, so let me just hop into the whiteboard and then let me show you what I'm about to tell. Okay, so today we are going to understand about this multi-model RAG. Okay, so in multi-model RAG, right, so suppose we have a document, right, we have, let's say, one document, let's say PDF. Okay, now this PDF is actually containing what? This PDF is actually containing, let's say, image, some text, right, some links, some header, so many things, right? Now how do you actually create an embedding from it, right? So first of all you need to segregate, right? Segregate that this is basically the image, text, link and header. Okay, it means that I am supposed to use the unstructured IO library. What it will do is that whenever I feed, right, whenever I feed my PDF or my data, right, unstructured is basically going to segregate into the different buckets. Okay, so, or different types. So let's say that from this document, right, wherever it feels that this is an image, okay, so it will try to segregate into the image type. Okay, wherever it feels that it has a text, so it is going to segregate into the text type. Okay, I will show you from the code as well, so don't worry. Wherever it feels that it has, let's say, a link, it will going to segregate into the link type. Okay, this many way. So in a way your PDF is basically what? Your PDF is completely unstructured. Okay, because everything is scrambled. Okay, everything is here and there. Okay, then how do you basically serialize everything? Okay, how do you basically say serialize everything and write it in one complete list? So what I mean to say is that suppose there is a PDF and this is like the single page of the PDF. Okay, in single page, let's say that this here there is an image of some person. Okay, here is some header, here is some header, here is some title. Okay, and here is some abstract or text. Okay, some text or some paragraph it is written, and within this some link is already attached. Okay, and then in the footer side some image and some address is given. Okay, so this is like a complete, like a single page of the PDF. Okay, now suppose when I give into the unstructured.io library, right, unstructured.io library, right, so what it will do is that it will try to like segregate everything. Okay, it will try to segregate, it will first reading it from the left to right, top to bottom, and let's say this is my header, so it is going to write this as a header. Okay, then the next to the header is basically the image, so it is going to write it as an image. Okay, similarly, like after the image we have a title, so it is going to write it as a title. Okay, similarly some paragraph or text, narrative text is there. Okay, there is some narration in the paragraph format, so it is actually write it in narrative text, right? In this way it is going to convert these things into a elements. We call these elements or a list of objects. Okay, a list of objects which is actually presented inside the PDF. Okay, so unstructured like does our task very easy. Okay, it actually like makes the RAG engineer life pretty easy, because you don't need to write a code explicitly just to catch up the different formats which is actually present inside your data. Okay, so we are supposed to use these things. Okay, so suppose that all these things are actually like present in my elements, right? So all these things are basically present in my elements. So this is, let's say, this is my element as a list. Initially it was empty. Now after like giving it to the unstructured, now my element is actually filled with full of objects. Okay, now my element is basically filled with full of object like this one. Okay, now what is the next step, guys? What is the next step? Just think. Okay, because we are actually creating a multi-model RAG, right? So apart from the text, there are some other thing is also there. Okay, now in the very first part of RAG, we were used to create the embedding, right? Here also we need to create a embedding, right? So in order to create the embedding, again, what we need to do, we need to initialize the vector DB. Okay, and inside this, I need to store my embeddings, correct? Now, in order to store the embeddings, I want to ask you one question, that like, are you going to store the embedding just for text, or you also store the embedding for the other elements as well, right? It has to be the embedding of everything, right? It has to be the embedding of header, image, title, text, table is also there, right? You need to convert these kind of embedding, right? So what should be the better way? So here, like in my algorithm, I am supposed to use the Gemini model, or let's say any other vision language model. Okay, Gemini model is basically the paid source, where like you need to pay some credit, or you want to go completely free, then you can actually use the any vision language model. So I would generally prefer Hugging Face. So inside the Hugging Face, I would be preferring like the Coin model. Okay, what does it do is that from the one single page, right, after like segregating all these things from the unstructured library, right, so I will be reading it, so in a list, right, so in a list I will be reading it from the left to right, because it is already been serialized. Okay, so I'm actually reading it from the left to right, and wherever I feel that there is actually a non-text object. Okay, what is the non-text object? It has image, it has header, it has table. These are actually the non-text object, means it has non-paragraph. Okay, it has an image, right? So wherever I see, right, see, I am going to iterate it in a list. Okay, this is my element list. So I am going to iterate it from left to right, right? And wherever I see that, suppose the first is basically a text. So for text, I will be doing the dense embedding. Okay, just the previous one, I will be doing the dense embedding, right? And then let's say here I have an image. Okay, so for image, whenever I am actually encountering the image, I am supposed to give it to this Gemini model. Okay, so that by inheriting the prompt template. Okay, by inheriting the prompt template. Okay, now Gemini model, so that by inheriting the prompt template. Okay, and in the prompt template, what I'm supposed to write? I'm supposed to write a basic prompt, so that my model could see the image, that what is actually present in the image, and it will try to write the perfect description in an English language. Are you getting it, right? I am not like directly creating the embedding of the image, right? What I am doing is that I am actually relying on this big vision language model to completely see everything, just as if like we as a human eye is watching. Okay, so we are actually like relying on the Gemini model, so that they could also see that what is actually present in the image or a table, and they will try to like write it in a complete paragraph format. Okay, now once this is actually converted into the list of, let's say, text, right, in a story format, then I will do the dense embedding. I hope you are getting it, right? So this is the previous one. This dense embedding actually added with this dense embedding, right? Then similarly, I go to this one. Now suppose that this contain in table. For table also, we repeat the same thing. So for table also, we are supposed to give it into the Gemini model to generate the caption from the table, right? To generate the caption, and then feed it into the prompt template, and then it will going to write the story in an English language, and then we will create the dense embedding, right? And then we are supposed to save it. Okay, so in this way we are going to iterate the entire list, right? And we are supposed to save it in, let's say, .txt format. Okay, we are supposed to save it in .txt format. So this txt one, right, this is the .txt file. It is going to contain the entire story. Okay, the entire story, whatever is actually present in your PDF format, right, it will going to contain the entire story in .txt format. Okay, so that you can actually proceed with the normal RAG, whatever you are doing. Okay, so this is basically that I wanted to show you that what we are actually proposing it as a multi-model RAG solution. And again, like you want to do the enhancement of this RAG, you can actually like try to do the two-way, right? First is actually like creating a traditional RAG, right? First is basically like creating the traditional RAG, or you want to create an enhance, then you can actually like enhance your RAG system, right? So we will going to show you one project as well, that how we actually build the multi-agent RAG system for our own surveillance camera. So you will going to get the insight that how much good it is, right? How much confidently I am saying that how much best it is actually supposed to give me the response. Okay, so this I would like to, so this is the strategy that I am actually basically following it, right, in my multi-model RAG. So let's hop into the code and notebook, and then again do the same thing, do the same stuff. Okay. Okay, so now what I'm going to do is that I'm going to import the necessary libraries in order to do the multimodal RAG. Okay, so these are the libraries. So I'm just importing this unstructured one. Okay, unstructured or PDF library, and I think this is the unstructured. So if I go to this unstructured.io, right? So you are going to get so many other functionalities over here. It is basically the open source as well, so you can actually use it and see there are so many other functionalities are there. Okay, so I would definitely urge you to in your free time that do visit the unstructured.io because it has a lot more things to offer. Okay, and again importing the unstructured, so I am actually using the partition PDF, which is going to partition the everything, every object, the image, table, text, link, title, header, everything, and then I contain it into the serialized fashion. Okay, so this is actually, and this is the PDF. Okay, so let me tell you the PDF as well, that how does the PDF looks. Okay, see, this is how the PDF is looking. So this is the online research paper that I have collected, and yeah, so this is the research paper on using the surveillance camera for marketing AI based image analysis delivered. So this is like the one text. Okay, and then this is actually the header, this is containing some image, right? And this is containing some flowchart as well, right? This is containing some image of their senior director in their team, and it containing some flowchart, the description, some diagram, some follow of implementation and some other things, right? There other citations, right? So this is basically let's try to make the multimodal RAG system using this PDF, right? So let me create one folder so that whatever the image that it is extracting, all this image will be present in that folder. Okay, so let me create one folder. So the folder name is actually the extracted image, right? Now let's try to run the partition PDF class. Okay, whatever we have actually imported, okay, in the above one. So here is like we need to set up the high resolution. All these things you will get it into the documentation. I will just head up the link below so that you can actually try to get and follow the documentation very easily. Okay, and this is very easy. Multimodal RAG is very easy, that's why. And then whatever you want to extract, okay, you want to like explicitly mention it over here. Okay, and then if you want to extract the English language, you can actually extract other things, right? And then when I run this cell, then everything, like the everything, so internally it is actually using this YOLO-X model just to detect the object. Okay, so let me give this one. Okay, so this is basically the output directory, and these are my output directory. Okay, and this is my PDF path. I need to create one more folder. Just a second, guys. Let me give this folder name as PDF, rename folder PDF, and let me put this PDF into this PDF folder. Okay, let me write this one. It has PDF. Okay, and let's try to run this. So what it will do is that inside this PDF folder, you can actually attach the list of PDF. Okay, and then it will going to take one by one. Okay, and then inside the every PDF, it will go pages by pages, and then it will detect the image, my table, my text, my header, my narrative text, my summary, my paragraph, everything, and it try to lineate it like in a proper linear object. Okay, which is a type of list. Okay, so let's wait, and then let's try to see that what does this element returns. Okay, now this has executed, and if I just run the elements, right, so you will going to see that the first part is basically the header, the second is the image, just like it is going from left to right, right? Header, image, title, and everything. Okay, and if I just try to find out the length of these elements, it has actually 98, which means that it has total 98 objects, right? And then if you want to print the metadata also, you can actually print it, right? So the first is like the category, image category, and then if you want to print the metadata of the image, then the second is basically the text category. So inside the text, it is internally doing the OCR operation as well. Okay, so it is going to write the image where Fujitsu is actually written, right? So the first element is basically the image, right? See, the first element is image, the 0th element, and the first element is image, right? And what does this image contain? You can actually see it from the metadata, right? Similarly, just go and just try to execute this. This is just for the showcase, right? Now what is this? This is basically, I have written it for my own sake, that just for checking that whichever element, that suppose that I only want to like check or fetch the object from the elements which has the type narrative text, okay, which has like the paragraph kind of a format. Okay, and if I'm going to run this, so my logic was I need to segregate it and put it into the index list. Okay, so you will see that out of these elements, right, so whatever the elements that it has fetched, okay, it has actually the type of list, right? So now from this, I am only going to fetch only which has the text type, so I can actually do that thing. Okay, so what I'm doing is that the element dot category is basically my narrative text, and inside this I am just appending my index. Okay, so these are the indexes that I actually scraped it, right? Similarly, this is basically the empty string, okay, just to whatever the things that I have already scraped, right? So I just want to read it one by one and I want to append it into my empty list, okay? So this is my knowledge, okay? These are just the entire knowledge of the narrative text, okay? And yeah, so this is basically one other import where I am just using the Google GenAI libraries just to find out the caption, okay? So now what I will going to do is that according to the algorithm that I have already showed you at the very earlier part of the video, that I am supposed to like reading it linearly, okay, like from index 0, index 1, index 2, and wherever I'm actually encountering the image, I'm supposed to call this Google Caption AI, right? And then append it with the previous text, okay? So this one. So these are just a prompt that I'm actually defining, right? And these are the prompts, and let's say I am supposed to run these things, right? So this part, meme type, so 1 second. So this is one image, this is meme type, which is like the image of JPG. See, if you see inside this extracted image, right, so you will going to see that all these images basically get extracted, okay? Because again, it's very simple, right? That it is actually like my partition.pdf library is basically like reading it from the left to right. So wherever it is actually encountering the image, I'm going to extract this image, right? So in this way. And yeah, and then this is just my element library. And this, what does this code will do? Okay, what does this code will do is that the logic is very simple. Again, I'm telling you, I'm supposed to read the element list, okay? And wherever I am actually encountering the text, I will just put that text into an empty string, okay? And then again move it to the next object of the element, okay? And wherever I'm encountering that, suppose that if the next object is a type image, I'm supposed to give it into my Google Gemini to generate the caption. And when it end up generating the caption, I'm supposed to append this caption with the previous text, okay? And then I'm going to append the follow-up captions or text, whatever, whichever type I am actually like encountering, okay? This function is going to do the same thing, okay? So what it will do is that I am first like defining my Gemini API, okay? And then defining my chat generative model. This is just that whenever I'm encountering the image, I need to decode this image, right, to pass it into my Gemini model, okay? And this is basically like a helper function for the image type, okay? And this is my knowledge base. So initially my knowledge base is basically an empty list or the empty string, right? Or even like in dictionary format, you can actually wanted to save it, you can actually do it as well, okay? Even if you have your own database, let's say if you have a 20,000 PDF, okay, you can actually save it in that case as well, right? Then what I'm supposed to do is that I'm supposed to like short everything, short every image, okay? Why this shorting is important? Because anyway, by default, my image is sorted, okay? But in case my image is not sorted, suppose there is a delay of reading the image. So because it is reading it from the top to left, right? So it's better to sort everything, okay? And then what I'm going to do is that inside my element, okay, my element list, okay, I'm supposed to go each object one by one, okay? And wherever there is a text, I am simply adding it to my knowledge base, and wherever there is an image, I am supposed to give it into my Gemini API to generate the caption and then append it to my knowledge base. Now suppose wherever I am actually encountering the figure, I don't need to use the Google caption for title because these things are already in English language, right? So after running this, you will going to get these things. See, after running this, how you will going to get these things, and this is very good, right? See, the header is actually given of type header, the image description is given, these are the description of the image, right? These are basically the foreground, this is the background. It means like your entire PDF, right, is now converted into the story format, right? See, this is like the page one, okay? The entire content is basically the page one, okay? Which where like this is also giving the boundary, like the background, foreground, okay? The text, it is also explicitly defining that this is basically my text and logo, okay? And then this is my image, okay? This is my image caption, okay? This image one is actually describing these things, right? Similarly, because anyway, how will you tell your AI model, okay? AI model you can tell by your English language itself, right? That is why. So and then this is the entire content of page second, okay? This is the entire content of this is the entire content is basically the page second, where it is actually like analyzing the image, visualizing the image, it is mentioning that what is header, what is box type, okay? So that everything, okay? So your PDF is now converted into a kind of textual story, okay? So that now you are supposed to create an embedding, dense embedding or a sparse embedding of these things, okay? So that is why like one of the major solution of making a multimodal RAG system, okay? What does people make a mistake is that they try to like encode the image itself and try to embeddings. This is very wrong. Why? Because first of all, you are actually encoding the image. So the image has been encoded, okay? And by far, if you see the encoded image, right, you cannot even read it, and you are expecting that even after creating the embedding of this encoded image, your machine would able to understand. Of course it's not, right? So it's always better to generate a very clean caption from the image or table or flowchart, okay? So that your machine would able to mind map semantically everything, okay? Because anyway, it is actually large language model, right? So it is basically trained to understand the semanticity, the ontological difference between the text, right? The relationship between the text, okay? That is why my intention intention to show you the multimodal RAG is that I need to convert everything into the text format. Okay, that is why. So now once these things are actually converted into the text, right? Now what I'm supposed to do is that I need to convert all this text, okay, all these extracted stories from the PDF into .txt format. So this is like the next. So this, let's say that this is my knowledge base. This is my knowledge base, and I am just storing this knowledge base into a knowledge base.txt format, okay, so that this I am supposed to create an embedding, okay, which means that this I will be using it as a document, and I'm actually supposed to run the exact same code of the traditional RAG or as well as the enhanced RAG, okay, the exact same code, okay. Instead of like giving it the document as here like the info.txt, I'm supposed to give the knowledge base.txt, okay, and I will going to run the entire same thing again and again, okay, and then it will going to generate the embedding, save it into the vector database, and like initialize the quadrant client and everything exact same thing, okay, so that when I show you the Streamlit chatbot and asking the question based on my multimodal uploaded PDF, it is actually supposed to give me a good set of response, okay, because all this embedding has already been saved now. All this embedding has already been saved, right? Where? In my vector database, right? Okay, so now we have actually like created the multimodal RAG, extracted the text part, and then actually save it into this full knowledge base.txt. Okay, this we have done in the last step. Now again, let's reiterate the same thing that we were supposed to do the RAG way. Okay, that these are my .txt data. Okay, and then what I need to do is that I need to create the chunking and other thing, right? So again, let's reiterate the same thing. Okay, so this is the code, the exact same code. Okay, then this, let me import these things, let me load the document, and this is my document, right? So let me copy the path, let me paste it, okay, and then these are my documents, right? The extracted documents, right, from the PDF. Let's create a chunk. This has, let's say, a chunk size of 19. Then let's generate the embedding, right? The exact same thing, right? So these are the embedding that has been generated, the dense based embedding, right? And then let's create a quadrant client, right? And apart from this, let me create one collection, okay? For creating a collection, let me give the collection name as Multimodal RAG demo, okay? Okay, so now this collection has been created, right? Now, if you want to see these things, let me go to this vector database and you will going to see. Let me refresh it. This is the multimodal RAG demo. Okay, so all this embedding has been mapped with their related chunk, right? Now, because all this embedding has already been mapped, right? So these are basically the retrieval. Okay, so I don't need to like go further. What I'm supposed to do is that because these embedding has already been saved, I can just copy this part, right? I can just copy these things and then paste it in my chatbot. Okay, so here I just need to give my collection name as, because from the chatbot I'm exactly doing the same thing, right? And the exact same thing, right? And let me try to run it. Streamlit run multimodal RAG.py and then run it, and it will work exactly the same way. Okay, so now you are actually querying with the embedding which is saved into your vector database, and those embeddings are the multi-model embedded embeddings. Okay, I hope you're getting it, right? And I am actually following the same stuff. Okay, so let me copy this OpenAI API key. So what is my OpenAI API key? This one, right? Control A, Control C. This is my chatbot. Enter. And yes, my quadrant cloud has been connected. Let me write hello, my name is Aryan and I am teaching generative AI content in my company Verify. Okay, now let me ask some questions. Okay, these are my documents, right? So this is my document. So let me ask some question regarding, can you tell me the process of using AI to analyze the camera? This one, right? Can you tell me the process of analyzing the camera? Okay, so it is telling that image capturing, data transmission, AI processing, output generation, visualization and action. Okay, this one. Okay, surveillance, video data, these things, right? And let me ask, who is this person? Who is Seichi Nakamura? Is a senior director at Frontier Computing Center, blah blah blah. Okay, in this Fujitsu Limited. So in this way, you can actually like understand, right, that how it is great, like that you can actually like try to create your own multi-model, generate the embedding from the very basic, right? See, my own intention of telling you and offering you these things is that so that you can actually try to build your RAG system for your company or for your organization from the very basic, okay, where you actually know the entire nitty-gritty, entire nuts and bolts of entire thing, okay? So in this way, you can actually like create your own multi-model RAG embedding. You can actually enhance it. I have already shown you the code and the process of how to actually enhance the RAG system, okay? So this way, you can actually try to build the entire multi-model RAG pipeline, okay? And then from that, if you click the deploy, you can like push this code into the GitHub and try to deploy it and serve it to the client as well, right? So this I wanted to show you, and this is not only like located to just for a PDF purpose, okay? You can actually try to upload the embedding of different PPTs and any other document which is like acceptable by the unstructured.ai library, okay? So like generally all those libraries which are actually like documents which are actually used in our day-to-day life, you can actually try to use it, okay? So this is just a one example of building a multi-model RAG agent, okay? And I'm hoping that you probably like know all these steps, okay? So this is what I wanted to show you in the multi-model RAG based system, okay? Now let me show you one final project that we have actually done by consuming all this knowledge, right, from different knowledge, attaching tool, making different RAG agents and other thing, how we build for our own system surveillance RAG agents, so that our camera, which is actually running on 24 hours, right? So those camera is actually feeding it into our database, saving all this data into our server, and then how our chatbot, the VGI agent chatbot, is basically helping us to counter the user response, okay? Whatever the client is basically asking a question, so it is supposed to give you the answer based on the report analytics. It is also try to give you some analytics report, some other use cases as well. So I'm going to show you our project as well. Thank you.